What is vitamin B? This is the story of how 8 different vitamins that share one letter, one history, and almost nothing else. They're called B vitamins, and in this video we're going to look at where they come from, what they actually do inside of you, how they end up in pills on a store shelf, and how the strange, sometimes deadly things that happen when you get too little of them or far too much. Let's start with something most people get wrong. When you pull a B complex bottle off the pharmacy shelf, you're holding 8 chemically distinct compounds that got lumped together more than 100 years ago because they all came from the same foods, namely yeast, liver, and rice bran. Early researchers assumed that they were one substance, but they were wrong, and by the time anyone realized it, the name had already been cemented into the textbooks. Here are the 8 in order they were numbered. B1 is thiamine, B2 is riboflavin, B3 is niacin, B5 is pantothenic acid, B6 is pyridoxine, B7 is biotin, B9 is folate, and B12 goes by the name cobalamin. Glance at that list and you'll notice some numbers have gone missing, because there's no B4, B8, B10, and no B11. Those used to exist as recognized members of the family. Compounds like adenine and inositol and PABA were originally classified as B vitamins, but closer investigation revealed the body either synthesized them on its own or didn't actually need them. So they got kicked out of the club, and the remaining numbers stayed where the others fell, like missing teeth in a gear. The whole concept of a vitamin, that word you probably take for granted, exists because of one man, a Polish biochemist named Casimir Funk. Back in 1912, Funk was studying compounds that prevented diseases like beriberi and scurvy. He proposed calling them vitamins, taking the Latin word vita, meaning life, and pairing it with amine, a type of nitrogen-containing molecule, because the very first one he worked with, thiamine, happened to contain an amine group. Later, researchers discovered that not every vitamin is actually an amine, so the final E quietly dropped off the word, but the name had already become too famous to change. To grasp how strange these 8 vitamins really are, we need to look at where they come from in the first place. When you eat a salad, your spinach is busy manufacturing its own B vitamins from scratch, because plants synthesize 7 or 8 without any outside help. Thiamine, for example, gets assembled inside a chloroplast of the plant cells. The same green compartments responsible for photosynthesis. The 2 halves of the molecule, the pyrimidine ring and the thylazole ring, are built separately and then snapped together. The whole operation is governed by something called a riboswitch, where the finished product binds directly to the messenger RNA of its own production genes and it shuts the factory down. This kind of feedback regulation is rare in any plant or animal cell. One B vitamin breaks the rule entirely. Plants cannot make B12. Not one of them. B12 is the strangest of the 8 by a wide margin, and the molecule ranks as the most chemically complex vitamin in existence, and at its center, a single atom of cobalt, the only metal found at the heart of any vitamin. That cobalt is what gives B12 its deep ruby red color, and if you ever cracked open a B complex capsule and notice it looks pink or red inside, that color is coming from the B12. Here's the catch. No plants produce B12, no animal produces B12, and no fungus produces B12. The only organism on Earth capable of making it are certain bacteria and archaea, the single-celled microbes that quietly run most of the planet's chemistry. Every B12 molecule in your body, in a cow's body, in a fish, in a fortified cereal, was originally manufactured from bacterium. Animals pick it up by eating bacteria-contaminated plants or grazing on soil organisms, and re-get it by eating those animals, or by taking a supplement made directly from bacterial cultures. This is why vegans have to think carefully about their B12. Some plant foods look like they contain it, including nori seaweed, certain mushrooms, tempeh, and spirulina. Here's what's actually happening underneath. Algae, like nori, doesn't generate B12 themselves. They maintain symbiotic relationships with bacteria living inside their cells. Spirulina and chlorella carry compounds that resemble B12 chemically but fail to function as B12 in human metabolism, and these are known as pseudo-B12, with research suggesting they can actively block real B12 from being absorbed. Nutritional yeast, the staple of every vegan kitchen, contains 0 B12 in its natural state, and only ends up with the vitamin if the manufacturer fortifies it on the way out of the door. Which brings us to the next obvious question: how this bacteria-only molecule ends up inside of a tablet. Vitamin B12 is too chemically complex to manufacture through traditional chemistry because a full synthetic route would demand more than 60 steps and would price the product out of any market. Instead, the entire global supply, more than 15,000 kilograms a year, gets produced through fermentation. Industrial tanks larger than 100,000 liters gets filled with sugar, nutrients, and seeded with one of two different types of bacteria. The bacteria grow for roughly 2 weeks. Cobalt is essential for building the vitamin, so cobalt chloride is added carefully because too much will poison the very microbes you're depending on. Once fermentation finishes, the cells are harvested, broken open with sodium cyanide and heat. The resulting compound, cyanobalamin, gets purified and crystallized into B12 that ends up in your supplement. The other B vitamins are mostly produced by chemical synthesis. Though fermentation has started taking over for riboflavin and biotin, thiamine, the very first vitamin ever synthesized, has been manufactured commercially since 1936 using a 15-step process developed by the company Merck, which, at the time, qualified as an extraordinary feat of industrial chemistry. Here's where things get philosophically interesting. People often assume natural vitamins from food beat synthetic ones every time. With B vitamins, that turns out to be false. Take folate, the proper name for vitamin B9, which comes naturally from leafy greens and whose name literally translates to the Latin word for leaf. Natural folate in food is chemically unstable, losing up to 75% of its activity during harvesting, storage, and cooking, and your gut has to enzymatically chop it down and reduce it before absorption can even begin. Synthetic folic acid, by contrast, arrives fully oxidated, stays stable for months or even years, and absorbs at roughly double the rate of food folate. Researchers had to invent an entirely new unit, the dietary folate equivalent, just to keep the accounting straight. The same story plays out with B12. B12 in animal foods is locked up inside proteins, and your stomach has to deploy acid and enzymes to release it before any absorption can happen. If you cross 50 years of age, or you take an acid-reducing medication, that release process loses efficiency fast. The crystalline B12 in a fortified cereal or a tablet is already unbound and ready to absorb, which is exactly why the NIH recommends that adults over 50 get most of their B12 from fortified foods or supplements rather than from meat. The next question is what these 8 vitamins actually do once they're inside of you. Here's the simplest way to think about it. B vitamins don't deliver energy, they are not fuel of any kind. Each one functions more like a key that switches on enzymes responsible for releasing energy from your food. And each one of the 8 is what biochemists call a coenzyme, a small molecule that an enzyme cannot function without. Because each B vitamin partners with different enzymes, each one carries a different job description. Let's walk through them. B1, thiamine. It parks itself in the middle of the Krebs cycle, the chemical engine inside every cell that converts food to ATP. Thiamine also sits on the membranes of nerve cells, which is precisely why a deficiency hits the nervous system so hard and so fast. B2, riboflavin, becomes the coenzymes FAD and FMN, which together drive the electron transport chain, the final and most productive stage of energy generation. Riboflavin also happens to fluoresce a vivid yellow-green, which is the reason a high dose of B-complex turns your urine startling neon yellow, because that color is excess riboflavin, literally glowing its way out of your body. B3, niacin, becomes NAD and NADP, the workhorse coenzymes for hundreds of chemical reactions across your metabolism. Your body can also synthesize a small amount of niacin from the amino acid tryptophan at a conversion rate of roughly 60 milligrams of tryptophan to 1 milligram of niacin. B5, pantothenic acid, becomes coenzyme A, which participates in around 4% of all known enzymatic reactions. The name traces back to the Greek word pantos, meaning everywhere, because the vitamin really is present in almost every food you eat. B6, pyridoxine, serves as a coenzyme for more than 100 enzymes, most of them involving amino acids. Your brain needs it to manufacture dopamine, serotonin, GABA, melatonin, and noradrenaline that powers your stress response. Hemoglobin production also depends on it. B7, biotin. It attaches itself to a small set of enzymes called carboxylases that govern fat metabolism and gluconeogenesis. A vitamin is also required to construct keratin, which is the entire marketing premise behind every hair, skin, and nail supplement on every drugstore shelf. B9, folate. Donates carbon atoms to the reactions that build and repair DNA, which is precisely why it matters so much during pregnancy, because a developing embryo is creating cells faster than any other point in human life. B12, cobalamin, partners with only two enzymes in the entire human body, but one of those enzymes builds methionine, which feeds methylation reactions across your metabolism, and the vitamin is also required to construct myelin, the insulating sheath that wraps your nerves. Strip away the myelin and the nervous system stops working properly, which is exactly what happens when B12 runs out. Three of these vitamins, specifically B6, B9, and B12, work together to regulate a compound called homocysteine, and elevated homocysteine has been statistically linked to cardiovascular disease and stroke. This is where the science gets messy. When researchers ran large clinical trials feeding people B6, B9, and B12 to lower their homocysteine, they expected to watch heart attack rates fall, but mostly the rates didn't budge. The stroke results came back better, though inconsistent, and one leading interpretation is that homocysteine functions as a marker of disease rather than the direct cause of it. The full story is still being assembled. Something most people never stop to consider is how long these vitamins actually stick around in your body. Because B vitamins dissolve in water, the general rule is that your body doesn't store them, and anything you don't immediately use gets flushed out in urine within hours to a day. Pantothenic acid, B5, has a half-life of around 1 hour, and biotin clocks in at around 2. Riboflavin disappears so quickly, it literally colors your urine on the way out. Thiamine carries a half-life of 9 to 18 days. Folate gets parked in the liver for several months, and B6 settles into muscle tissues for a few weeks. B12 breaks every single one of those rules. The molecule is the only water-soluble vitamin that gets seriously stored anywhere in the body. Your tissues hold somewhere between 2 and 4,000 micrograms of it, more than any other vitamin, with about half of that supply sitting in the liver. The plasma half-life of B12 runs about 6 days, but inside the liver, the half-life stretches to closer to 12 months, and the body actively recycles B12 by sending it through the bile back into the intestine and reabsorbing it through a loop called intrahepatic circulation. B12 is the only water-soluble vitamin excreted mainly through feces instead of urine. What this means in practical terms is striking. Stop consuming B12 today completely. No animal products, no fortified foods, no supplements at all. And on average, it'll take between 2 and 8 years for the first signs of deficiency to surface. A theoretical lower bound suggests the body can keep running on its reserves for as long as a decade. That long fuse is one of the main reasons B12 deficiency goes undiagnosed for so long, because by the time symptoms finally appear, you've been quietly draining your reserves for years. You might assume, after all, that this is the only problem with B vitamins, is failing to get enough. The modern story is also about getting far too much. Vitamin B6 is the cautionary tale of the supplement era. Most B vitamins are considered very safe because the excess gets flushed out so quickly. B6 is the major exception. Chronic high doses can inflict permanent nerve damage, a condition called sensory peripheral neuropathy, and it typically arrives as tingling, burning, or numbness in the hands and feet, along with balance problems and loss of vibration sense. For decades, the working assumption was that you needed more than 200 milligrams a day to develop neuropathy from B6. That assumption was wrong. Case reports now document people developing neuropathy from much smaller doses. One man in his 60s developed the condition from drinking 6 energy drinks a day, each of which contained 300% of the daily value of B6. Another case reported recently involves someone developing neuropathy from just 6 milligrams a day in a routine multivitamin. An 87-year-old woman developed sensory motor neuropathy after 4 years of taking the standard B complex. What nobody expected was the regulatory hammer that fell in late 2025. The Australia's Therapeutic Goods Administration delivered the most significant regulatory action on B vitamins in decades. After reviewing 250 reports of peripheral neuropathy linked to B6 supplements in their adverse event database, they ruled that products containing more than 50 milligrams of B6 per day will become pharmacists only by June 2027. Products carrying more than 200 milligrams will stay prescription only. Labels warning of peripheral neuropathy are now required on any product containing more than 10 milligrams. Here's the unsettling part. Toxicity from food alone is essentially never seen because this entire problem is purely an artifact of the supplement era. Biotin, B7, runs a similar gauntlet. The adequate intake for an adult sits at roughly 30 micrograms a day. The hair, skin, and nail supplements lining every pharmacy aisle often contain 5,000 to 10,000 micrograms, which works out to as much as 650 times what the body actually needs. Most of that excess gets excreted without incident. High biotin in the blood does something nobody anticipated, namely interfering with the whole class of laboratory tests that rely on a chemistry called biotin streptavidin. The consequences are direct. Biotin supplements can throw off your blood test results. Thyroid hormone tests including T3, T4, and TSH can come back wildly inaccurate. Pregnancy tests, troponin tests used to diagnose heart attacks, hormone tests, and certain cancer markers can all produce false readings. The FDA issued safety communications in 2017 and 2019 specifically warning about biotin interfering with troponin tests, and the agency confirmed at least one death in which a patient on high-dose biotin received a falsely low troponin result and was discharged home. A Mayo Clinic study found that more than 7% of emergency department patients had biotin levels high enough to interfere with thyroid testing. People have been misdiagnosed with hyperthyroidism, others have had real conditions completely missed, and almost none of them knew their supplements could do this. One more modern deficiency story deserves attention because cases keep multiplying. The culprit is nitrous oxide. Nitrous oxide oxidizes the cobalt atom sitting at the center of vitamin B12 and inactivates it. Heavy users can develop a functional B12 deficiency even when their blood levels appear completely normal. In one published case, a 34-year-old man arrived at the hospital unable to walk. His father had hauled 40,000 used nitrous oxide cartridges out of his apartment. The young man had been using more than 600 cartridges a day for 7 to 8 weeks. In a more recent case, 2 women in their 20s and 30s developed myelopathy, meaning spinal cord damage, after 3 years of regular use. Now, let's bring this back to where we started. The B vitamins are 8 chemically distinct compounds that share a single letter because 100 years ago, scientists couldn't tell them apart. 7 of them come from plants that build them inside chloroplast and mitochondria, while B12 comes from bacteria, including the same bacterium that creates the holes in Swiss cheese. They function as the coenzymes that convert your food into energy, your amino acids into neurotransmitters, and your dividing cells into more cells. Most of them vanish from your body within hours or days. B12 can persist for a decade. When humans didn't get enough of them, we got beriberi, pellagra, and pernicious anemia, and millions of people died before anyone understood the chemistry involved. Now that we can manufacture them by the ton, the problem has flipped on its head and deficiencies still exist, particularly among vegans, older adults, alcoholics, and recreational nitrous oxide users. A new category of harm has emerged alongside them, where people take too much and pay consequences that nobody warned them about. 8 letters, 8 molecules, and one of the strangest families in human biology. If you enjoyed this, please hit that like button, and to keep up with my future content while I'll cover other vitamins and supplements, please consider subscribing. I hope you're all happy and healthy. Thank you.